Let's see. Hey.
Good morning.
You okay?
I'm all right. I got a puny kid at home.
Oh, bless your heart. Just trying to get things hooked up here, guys, and I gotta take row. So let's see. Okay. Let's see, Caleb, Cooper, Gage. Oh, Irene. Is Irene amongst us? I don't see her. Okay. Okay. Anna's there. Grant. Oh, okay. Okay. All right. Okay, so guys, what we're doing is lesson 3 today. So if you would have lesson 3 pulled up. It's lesson 3. Okay. So I'm going to share my screen and pull up the OneNote, and I need to go back. Okay, lesson 3. All right. So, I need to. All right, boys. Now, let me say something before we get started with the lesson. I've gone through and I'm working on grading, and some of you did not do the Ed puzzle assignment. Okay. So if you don't do it, that 0 will remain. So I'm just giving you a heads up. If it's not completed, it will be a 0. It was assigned. It's still in Google Classroom. So, so just look at what's been posted, and those that I've returned the grades that I've graded so far. So just be aware of that. Okay, so we are still talking about sequences, and now we're going to be able to talk about how do we know the difference between them, the arithmetic and the geometric. Okay, so wait, that's the cool down. That's not what I want. This is what I want. But this whole lesson, again, is we're going to be able to determine how to identify the different sequences. What would they look like? Okay, so right off the bat, they're going to start us with function notation. Do y'all remember function notation? Okay, what that is when it's written in terms of as a function. Okay, when it's written as a function and it's a mathematical expression where you have numbers that you're going to plug in for n, but it's a function of f, okay? So all they've done is just written it as a function of f. So when it's in the parentheses, that's the number that you're substituting for n, okay, and solving. This is our function, 3n minus 7, okay? Something's coming into the function for n. You're solving it with this function rule and coming out with a new output, okay? That's what's happening. So right now, take 5 minutes and work through these 4 examples, okay?
Miss Tyner. I need to leave real quick because something's up with my screen. It's not showing yours, but I'll be right back.
Okay. And I gotta turn the air back on. It's got hot in here again. All right, so you guys online, were you able to find lesson 3? Okay, all right. If you can't, just put it in chat. Okay, and I'll help you find lesson 3. So. All right, so let's look at what we're doing here. Again, you had a function, and the function takes an input, multiplies by 3, and subtracts 7. Okay, so what did you get on the first one? The f of 10. What'd you say? 23. Everybody get 23? Okay, so again, this is just function notation, but what's in the parentheses is what you plug in. Okay, and your new output is 23. Okay, all right, so what'd you say? 22. So again, let me show you how that, so you have this, and then okay, so we had this function. Um, let me go back because I need to, let me erase this. Let's see, what am I erasing? All right, so you had this big picture. The big function was 3 and then 10 minus 7, and then they added a minus 1. So you'd already had 23, and then minus 1 would make it 22. Okay. All right. So what about the next one? 20. Yes, it would be 20 because this is what happens in it. Anybody struggling with these? Everybody okay? Okay. So let me, all right. So this is how you had f of 10 minus 1. So this would be 3 times 10 minus 1, then minus 7. So this is 10 minus 1 is what? 9. And then 3 times 9, 27. And then minus the 7 to get 20. Okay? All right? So you're substituting what you're given in for n and solving. Now, What did y'all get for the last one? Y'all didn't get it? Anybody, y'all struggling? Okay. All right, you're still using the same function each time. It's just two different inputs. So what you're doing is you're saying 3 times 5 minus 7 in one set of brackets, then minus 3 times 4 minus 7 in another set. So it's like you're doing two separate functions, okay? So 3 times 5 is 15, okay? So 15 minus 7, what's 15 minus 7? 8. Then you come over here, 3 times 4 is 12. And then you do 12 minus 7, and you get 5. So 8 minus 5 at the end would just be 3. Okay? Again,
Wait, the whole answer is 3?
the whole answer is 3.
Oh, I thought we were going first.
No. So what they wanted you to do was substitute two different numbers in separately into this one function rule, okay? So you had to simplify each of those and then subtract your final two answers, okay? So does it help sometimes to put parentheses and brackets in to identify the differences? Yes. Okay. All right. Questions about that? Okay. All right. So here we go. Here are the values of the first 5 terms of 3 different sequences. You've got A, B, and C. For each sequence, describe a way to produce a new term from the previous. And then if the patterns you describe continue, which sequence has the greatest at the 10th term? And which of these could be geometric? Okay. Geometric is the one where you multiply, that you have a growth factor to multiply. All right. So you're going to have 20 minutes to think about this one. So think about how you could define these sequences. Kaden, where's your mask? What are y'all throwing over there? Bless you. Bless you. So Chloe Jones is, oh, I didn't see it back there. Okay, sorry.
Ms. Tanner, will you double check to see if Luke is trying to get back in?
Okay. Okay. Yes. Help you find letter B? It doesn't show him, Chelsea, waiting.
He was having some internet issues.
Yeah, I saw that message.
Miss Tyner, can I run to the restroom?
Yes. Okay. Anybody figure out B, sequence B? Okay. So any of my online kids, did y'all figure out letter B? If so, just put it in the chat, but we're gonna talk about it.
So can you help us with B?
Yes, well, we will talk about it.
Well, I can't continue without B.
Well, no, you can go ahead and do the rest of it.
How am I gonna know which one the second biggest is?
We'll just skip it for now. When Andrew gets back. Okay, so the main thing we're learning here with all this is that you're comparing the different sequences and you're trying to recognize if the sequence is arithmetic, geometric, or possibly neither. Okay, so there's some things that we could say about these sequences.
Miss Turner,
Yes,
can I use the restroom?
yes, that's fine.
Okay.
So there's some things that we could say about these sequences that might be alike, you know, talking about what they have in common, talk about what they have different, maybe one that stands out that, you know, in your mind, would it fall under either one of those categories, arithmetic or geometric? Okay. So as we work through this, what happened with letter A? What's happening each time in A? It's plus 10, okay? So you could figure that out, you know, by maybe doing the difference, but you can see that it's add 10 in it each time. So what would be the, let's see. Okay, so it's n plus 10 would be its function rule, basically. And it's adding. Are you adding the same number every time? Yes, we're adding the same number each time, okay? So when we think about sequences, as far as geometric or arithmetic, this one would fall under what? Yes. So sequence A, you're adding, it's n plus 10, and because it's the same number each time, it's the arithmetic sequence, okay? That's what you have to keep in mind as you look at the sequences. Is it the same number consistently? Is it happening over and over again? How did I find it? By adding, multiplying, okay? In this case, it was adding, so I knew it was the arithmetic sequence. Now, sequence B. So everybody struggled with that one, is that right? Anybody?
Is it like to the exponent?
Well,
I know. So I noticed with B that some of the numbers are adding 20, but with 15 and 30, that's not working.
okay,
Because if it was 15 and 30 and it was adding with 20, I believe it would be 35. I think, if that's how I'm looking at it, but I don't think that's right.
okay. No, you had the right idea. You had the right idea because each time, did anyone else see that? From 0 to 5, they what?
Add 5.
Add 5, but 5 to 15, add 10, 15 to 30, 15, 20 to 50, add 20. So, okay, so are they using the same number every time?
No.
No. And what they're doing, let's see if I can, okay, they're going up, they're taking the difference and adding 5 to that, okay? So basically, it's a previous number plus plus the difference in 5, okay? So the next number being added would be 25, wouldn't it? So it's the difference of terms plus 5,
How do you write that in a equation?
okay? So our next question, would that be a sequence? No. It's not a sequence because is it a consistent number? No. You're not doing the same number over and over again. Okay, so that letter B is not a sequence. It's not the same common ratio, same common growth factor every time. Yes, it's a difference, but you're adding 5 to the difference. So there's no consistency. You can't say that any number like 200 and another numbering, find the sequences for the 25th term because it's not happening on a regular basis. Yes, Kaden. Yes. Okay, so letter B was a little bit different than the other two because it doesn't follow a consistent pattern of being able to write it out as same thing every time. Okay, Look at letter C. What's happening there?
No, you're adding the latest.
So 2 to 4 is 2, and then 4 to 8 is 4, 8 to 16 is 8.
Okay. You're doubling the previous number. Okay. Another way they want you to look at it is multiply. So by 2, yes. So when you say double, okay, you want to think that's actually in terms of multiplication. All right, you're right. They are doubling each number. So when you say double, that means times 2. Times 2, okay? All right. So on letter C, multiply by 2. Now, what kind of sequence would C be? Geometric, wouldn't it? Because you're multiplying by the same growth factor. Okay, so it's geometric. A was arithmetic and B was neither. Okay. All right, so let's move on. If the values you described continue, which sequence would have the second greatest value? Okay. Caitlin says B. Anybody else figure it out? Okay, so let's look at the values up here. Okay, the first one, okay, we know adding 10, the numbers are probably going to get, they're just going to be 10, families of 10, aren't they? So this is a family of 5. So 5 more figures, if I can find my pen, it would be 80, 90, and 120, right? Okay, so then if you did the B one, okay, we're adding 25, so that would be 75, and 30 would be 105, 35 would be 140, 40 would be 180, and so 25, 30, 35, 40, 45 would be 225. Is my math right?
I didn't go that far.
Okay.
Yes.
All right, so times 2 here would be 32, 64, 128, 256, 256, and 250 is 512. Okay, so sometimes you might have to work it all the way out to figure out, and those are the 10th number in each of the sequences. So Caitlin is right, the one with the second highest would be B. It would be B. Okay? Because it had 225 and C had 512. All right. Then they ask us which one of these is geometric and how do you know? So which one is geometric? C is geometric. And how do we know it's geometric? because you're multiplying by what? By 2. And it's a common growth factor, okay? It's the same number every time. And that is a must. It has to be the same to be identified as a sequence. I mean, as a geometric sequence. Let me back that up. Geometric sequence. Same number being multiplied to be a geometric. Okay. All right. Look at lesson 3.3. Okay, we have Jada and Maya are trying to decide what type of sequence this could be. Okay? So look at that table of values. Okay? See if you can figure it out. You might even have to graph it. Well, you can graph it there on the side. But let's take 15 minutes and see if we can figure out who's right. Who's what? Yeah. So has everybody got this decided? Anybody having trouble with it? Okay, so what we're focusing on today is being able to try to determine the difference, right? Being able to figure out the difference between arithmetic and geometric, right? One thing we know for sure is got to be the same consistent, either common difference or common growth factor. So as you're looking at 3.3 and trying to is who's right? You have to think about that. What's happening to this table and the values that are in it? Okay. What would be the common ratio or growth factor? Is it multiplied? Is it add and subtract? Okay. So what did y'all figure out?
Jada.
You figured out it was Jada? Okay. So Jada says that it's geometric because each row is being multiplied by 3. Okay. All right, so let's see. One thing you can do, look at the values. Did you notice that the values went 1, 2, and jumped to 5? Did you catch on to that? Okay. All right, so let's think about the values. Okay. So we know that the first term is 1, and then the value is 2. And then it goes 2 to 6. Okay, so when you're looking at that, you're thinking right now that it's 2 times 3, right? And that's what Jada said. Okay, so let's put the values for 3, 4, and 5 up here. Okay. All right. So multiply by 3. 6 times 3 is what? 18. But what would that's all the way down here for the 5th term. So what happened to 3 and 4? Okay, so let's rethink it. We know it's not times 3, don't we now? That could be with the first and second, but here's what they're wanting you to see. In order to find the sequence, you cannot just use the first 2 values, can you? No, because within the first 2 values, there could be a lot of different sequence rules, couldn't there? Yeah, you need to find at least 2 more to make it a true statement, okay? So let's think about, Jada's not correct because when you multiply times 3, it's all the way down here for the 5th value. So somehow he doesn't have, or she doesn't have 3 and 4, okay? So what would be for the number 3 if we used a different sequence? What else could be happening? What'd you say? 10, why do you say 10? Yes. Okay. It is +4. So y'all found the other way you could, it is 10. And then the next value would be 14. Now, does that go to 18? Would 14 go to 18? Yes. Okay. So be careful as they give you these to have you figure out what the sequence is. Every term holds a place value for the sequence. Okay. Now, if you graphed it, you would have seen also that it could not have been geometric. Let me go down here. You had 1, 2, 3. We know 1 was up at 2, and 2 was at, let's see, that would be 4, 6. And 3 would have been, let's see, 1, 2, 3, right here. Now, what I want you to see on this graph, what kind of graph does that look like? Yes. And what did we say about arithmetic sequences? They're linear, okay? They're linear. So if you had graphed the values, you might have seen it that way. If it makes a straight line, which means it has the same common ratio with the slope of the line, making it linear, it would have been arithmetic that way. You would have seen that Maya was correct, okay? All right. So questions about that? Anyone disagree? Everybody see that Maya was right and not Jada, right? Okay. All right, so let's look at the lesson summary, okay? Let's talk about some things that we've learned from this lesson. Okay, but my computer's going to die here in a few minutes. Can someone tell me something they've learned today from this lesson? Well, let's look at this sequence that we've got up there. It says consider 258. Okay? What's happening in it each time? What's happening in the sequence each time up here? Okay? So it's a consistent common ratio, right? So when you see that, you know it's what kind of sequence? Arithmetic, right? Arithmetic. If you'd rather say arithmetic, I'm trying to say the proper way, arithmetic, but that's what this one is. Okay? It's the same common number being added every time to get the next. Okay? And that's what it tells you. Previous term with a constant added. All right. Now, we looked at a geometric one. What was happening with that geometric sequence? In that second lesson that we did. Or look at this sequence. This 3, 6, 12, 24 is not arithmetic or arithmetic because we know what's happening to this one. What's happening to get the next number.
Times 2.
Wait, times 2. You were close. Times 2. So if it's the same number being multiplied each time, that is a what sequence? Geometric. Okay? All right. So that is the difference between them. One is adding or subtracting the same common number. Okay? The other one is multiplying by the same constant number. Okay, and that is what I'm trying to get you to gain from this today. We've talked about both of these sequences now, so we need to know the difference between them. Okay? All right, so this one, okay, it's going down by the same number of what? 180.
20.
Right, so it's being subtracted by the same number, isn't it? So which sequence would that be? Right. Now, we found one today that was neither, okay? And how you know it's neither is because it's not the same constant number being added or multiplied every time. That's the key word here, guys. It has to be the same consistent number to fall in either of those sequences. All right. Anybody confused about these two sequences at this point? The cool part is we're fixing to get in, we're going to learn how to write the recursive and the explicit formulas when we find a sequence. Okay? You'll be able to take that and write the 55th term or the 100th term just based on the formula, okay? Knowing which sequence it is and how to develop the correct formula, okay? All right, so at this point, does anybody have questions about these? Okay. All right, so here we go. Here's the cool down. Here's the cool down. And I'm gonna have to put the cool down, guys, in Google Classroom. So let me go pull that up. I should have done that already. All right, so those of you in class, if you wanted to write it on paper and turn it in, or just use your Chromebooks. Let me put it in Google Classroom and y'all can use your Chromebooks to do it with. Let me go there to find it. And what you can do is download or open it in Google Docs and type on it, make yourself a copy and type on it. It's not there yet, but I'm getting it. I'm gonna put it there. But as you're working it, think about everything we've talked about today in class. Being able to tell the difference between the two sequences and what does that mean? Either adding, subtracting, or multiplying. Uh-huh. Any kind of what? No. Yes. I'm so sorry.
You're good.
Okay, so let me go now to, okay, so I'm gonna put this in Google Classroom. And it is an assignment with a grade. Some of you are trying to just skip over all the assignments, and your grade will reflect it. Okay. Okay. And again, what you're gonna do is download this and make yourself a copy so that you can type. Let's see. Uh, and y'all can't, I'm gonna give you till, and put it under Algebra 2, Unit 1, and assign it. Okay, so hopefully when you refresh, it'll pop up on the assignments. Under Algebra 2, Unit 1, okay? All right, so I'm gonna pull back the cool down. Once you get done with the cool down, move on and work on the practice problems, okay? Here's the thing about the practice problems. You've got to do them, okay? They will appear on quizzes. So if you don't know how to do them, you're gonna fail the quizzes. So once you get done with the cool down, you need to move on to the practice problems. You guys have the practice problems done? Hayden, do y'all have the practice problems done? The lesson through? Okay. Now, do you have Khan Academy done?
No, I did, but I just wait till I get home.
Well, you need to be working on something. You can do the problems without earbuds. And some of you need to check to see if I returned a 0 back to you.